Number 8 on StatCrunch, or using StatCrunch. So click here, StatCrunch. I got the numbers in here, but this isn't a regular linear regression like we did for number 4. We want log of y. So I need to take log of all these y values. So what you can do is go to data, compute, and then expression. And we're going to build an expression that is going to go in this column right here. So hit build. Okay. We want log, and you want to choose log base 10. I tried just regular log. For some reason that didn't work. But log base 10, and I go add function. And then I click the variable that I want to take the log of. I want to take the log of all the y values, because that's what the problem has, log of y. Okay, so add column. So we're going to add the whole column. It's going to compute this whole column. It's right behind here. Let's see if I can move this stuff. It's going to compute this whole column and then put it next to it here. And then so we can label this. Oh, maybe I got to go OK first. So label. Looks like I got some options here that I've already used. Just going to go log 10 of the y column. So this is saying that I'm taking log base 10 of y. Hit compute. There's my column. So this is, if you did this on the calculator, just push the log button of 68, you should get this number. Log of 141, you should get this number, and so on. Now we want a linear regression with this column and this column. We want to see how closely matched these two columns are. So simple linear. X variable, log of 10, hit compute. So they have pretty high correlation coefficient. Closer this is to 1, the closer they are to being matched. So this is pretty closely matched. Oops. All right, now I got to enter the number. This is the slope to 3 decimal places, 0.205. And this is the intercept, 1.659. Hit check answer. Good. Okay, which does this look like? I think this is the one I got wrong on in class today. Hit to the right. Okay, so 1.87 is about 3. So which one has 7? I don't want to use this one that goes to 7,000. I think that's the original data, so we're going to get rid of that one. This one was 7,000. Our x values only go up to 7. Our y values, it looks like our y values go up to like 1,200, but we actually only go up to 3. So we want the one that has a y value going up to about 3. This one has a y value close to 7, so we know that's not right. I think this is the one I picked in class. It's going to be this one, because and this matches the data the best. 1, maybe I can make it bigger so you can see it pretty clearly. Here's 1, here's about 1.8. Here's 2, here's 2.1. Here's 3, 2.2, just a little bit more than this one. Right, I'm just getting these numbers here. Here's 7, just a little over 3. So this one lines up the best. Okay, now we're trying to determine if this looks better for the data or this one. This is not the kind of pattern we want to see. You can see it kind of curves below the line and then goes above. This is not a good representation. A line is not a good representation of these numbers. This is the original data. This is the data using this log base 10 of the y values. So this is a more accurate linear regression than this. So we got to word it that way. A linear model is blank appropriate for the transformed data, is more appropriate after we've transformed the data than the untransformed data. So this is better representation with a linear model than this. Okay. The only other one that might be a little tricky is 11, but you just have to take log of both of them. So over here, you'd take log of the x and log of the y and do a linear regression on that. So how would that look? We've already got log of the y. Take log of the x with that expression. I can do that quick here, so it'd just be compute, build. We want log 10, add function, and this time we do the x also. Okay, and then hit OK. And then I just want this to read log 10 of x, hit compute. And now I've got another column. Here's my log base 10, here's my log base 10 of y, here's my log base 10 of x. And then you would do a linear regression. X variable is log base 10 of x, y variable is log base 10 of y, hit compute, and then these are the numbers that would go here. Obviously, these numbers don't match up with the ones I have here, but that's how you do this problem. And again, it'll graph it for you, different things like that. So, all right, hopefully that's all you guys need to get through this assignment using StatCrunch. Obviously, there's a few problems that you can't use StatCrunch. I think number 9 is one of them. I have a video for this, and actually I think that's the only one you can't use StatCrunch. There used to be 2, but there's only one. This is the same ln of x, so it's the same. That's what a couple of the other problems were. All right, I hope you guys can make it through this assignment, and if you have questions, please ask.